All right, our next presenter is, we have Dr. Matt Foster, our cotton corn specialist here, newly hired. So we'll get you loaded up here, Matt. Yeah, take that up.
All right. Well, good morning, everybody. I want to thank y'all for being here today. I also want to thank Dennis, Callie, Mr. RL, and Bruce for giving me the opportunity to speak here today. Like Dr. Cater said earlier, I'm the new corn, cotton, and grain sorghum specialist. I started last week. I'm originally from Vidalia, Louisiana. I did my PhD in agronomy in 2018 at LSU, mainly focusing on soybean response to dicamba rates. And for the past couple of years, I've been an extension agent in South Louisiana working with sugarcane. With that being said, all of my research has been on soybeans and sugarcane. So I didn't have any data for corn. So I reached out to Dr. Jason Kelly, a corn specialist in Arkansas, Dr. Eric Larson, a corn specialist in Mississippi, Mr. Dennis Burns, and I'm using some of my predecessor, Dr. Dan Frommy's data that he conducted at Dean Lee in Alexandria. So I want to get started. There's a lot of factors that can affect corn yield, whether that be weather, your inputs, your hybrid selection, your planting date, plant population, uniform emergence is very key, fertility, your drainage and your irrigation practices, weed, insect, and disease management, as well as a timely harvest. These are just a few that affect corn yield. There's a lot more. So what is the optimum rate recommended for Louisiana? 32 to 36,000 seed per acre. There's lots of discussions, about increasing plant populations, high yield winters. What about normal yields, irrigated versus dry land production? What is your actual yield potential of that ground? What about your hybrid response to the different populations? You got full flex ear hybrids and you got a fixed ear hybrid. The flex ears tend to do better at a lower population. Also, there can be negative effects to increasing population, reduced economic returns. You spend too much money on seed, lower yields, and lodging potential at some of those higher populations. And that's going to depend on hybrids. So here's a graph from Dr. Jason Kelly, University of Arkansas, corn response to plant populations. He had 5 hybrids on 38s. And this is just showing you how different hybrids respond to different plant populations. You can see you have a pretty wide spread of how each hybrid responded. Some preferred a lower population, some responded better at a higher population. And this is, like I said earlier, this could be due to that flex or a fixed ear type on that particular hybrid. Here's a picture from Dr. Kelly. It's the same field, different hybrid, planted at the high populations. You can see lodging was a problem in this hybrid at that population, whereas in this hybrid, lodging was not an issue. It could take that higher population, the stress from that higher population, a little better than that hybrid on the right. So here's some work conducted by Dr. Dan Frommy at the Dean Lee Research and Extension Center in Alexandria, Louisiana. From 2015 to 2017, he looked at 8 seeding rates from 20,000 all the way up to 55,000. And you see your majority of your main yield right here at your 35,000. You do see a bump, when you bump it up to 40. But like I said earlier, are you going to get an economic return from bumping that population up that high? And then you see it kind of, levels out, and then it goes up to 199. That's going all the way up to 55. And again, here's the average of trials from 2015 to 2016, some of Dr. Frommy's work. And again, it's still showing you in that range, that 30,000 to 35,000 range is kind of the sweet spot where you see the majority of your yield is made. And you can see slight bumps from increased population, but will you see an economic return on that is the question. So here's another summary of some of his trials at Dean Lee. These are on 38-inch rows. You have your bushels per acre and your seeding rate went from 20,000 to 55. And as you can see, it still follows the same sort of trend as you get to 35,000. that's your, kind of sweet spot where you're gaining most of your yield. You're not really getting a benefit to increasing that population. This is from Dr. Jason Kelly in Arkansas. It's a Mariana location. He planted 5 hybrids on 38-inch rows, and 5 plant populations have replicated 4 times. Now, their recommended population is represented by this red line. It's right about 34,000. And as you can see, most of their yield kind of follows the same trends as what we've seen in Louisiana. The majority of the yield was made right here at 34,000. Here's another location, same test, and it follows the same trend. This is their recommended yield at 34,000, and as you can see, the majority of that yield was made right in there. And you do see a slight benefit to increasing population. Here's a slide he shared with me, dictating cost. So you have your plants per acre on the bottom, your yield, and then as you can see, you go up to 15,000 all the way to 37,000. And as I mentioned earlier, you do see increases in yield, but your cost also goes up when you increase those seed populations, your cost per acre. So in summary, plant populations of 32 to 36 K will achieve optimum yield for most hybrids. You can get higher yields with higher populations, but will it pay? That's the question. It depends on the hybrid, like I said. Increasing your plant population does not automatically increase yield. You have other limiting factors. By increasing that plant population, is it going to make one of your limiting factors worse? Nutrient availability, water uptake, is it going to make that limiting factor worse is the question. So I want to switch gears to row spacing. The most common row spacing in Louisiana is 38 inches. And I often ask why, because the majority of the corn belt is on 30-inch spacing. I think it's because that's the way it's always been done. It could be associated with furrow irrigation practices, maybe because of cotton being grown in the region. But advantages of a narrow row spacing, it's the standard in the corn belt, and they're even looking at narrow row spacings for corn 20s and even 15-inch spacing. Advantages of 30s, you get faster canopy closure. You get better weed control. You get a more efficient utilization of your resources, whether that be nutrients, light, and water, due to that improved spacing, that seed spacing on the row. Potential for increased yield. Mississippi showed an 8 to 9% increase, whereas nationwide they show an average of a 10% increase when swapping to that narrow row spacing. Here's some data from Dr. Eric Larson in Mississippi. They did a study comparing what they call narrow rows, which is 30-inch, wide rows, which is 38 to 40s, and twin rows. And as you can see, there was a significant difference between the narrow rows versus the twin rows and the wide rows, but there was no difference between the wide rows and the twin rows. Just wanted to share some of that data that he shared with me. And as I mentioned earlier about your seed spacing geometry, if you look here at 36,000, same population, but you vary the row spacing, you're at about 6 inches between the seed at a 30-inch spacing, and then you're at a 38-inch spacing, you're about 5. So you're spacing those seed out. They're not competing for nutrients availability. You don't have that. You have less interplant competition with that higher seed spacing. What about wide beds? I spoke with Mr. Dennis Burns about some projects that are going on at the Northeast Research Station. So a 60-inch wide bed allows for 2 corn rows to be planted on each bed. It also allows producers to still plant cotton, either a 2-in, 1-out configuration, or in a 60-inch center, which is being evaluated at the Northeast Research Station. You can also drill beans on the top of it. Have 15-inch spacing, 4 drills of beans on the top of it. It just gives you a variety of options. You can also, there's been talk of people getting into row rice, and that could be a benefit to go into that configuration. I know some growers have swapped to the configuration. They're still trying to figure out if it works on their operation. But my future plans are to collaborate with the LSU ag center scientists and county agents Like I said, I don't have any data. I just started last week, but I'm very much looking forward to producing some of my own data regarding these issues. And I want to evaluate the 30s versus 38s and evaluate 30-inch ag practices on the wide bed. So the acknowledgements. Dr. Jason Kelly, University of Arkansas, Dr. Eric Larson, Mississippi State, Mr. Dennis Burns, and Dr. Dan Fromme. I used a lot of their information for this presentation. And I want to thank everybody for being here. And with that, this is my contact information. I'd be glad to entertain any questions. I look forward to working with everybody and meeting everyone throughout the state. Thank you.
Anybody have a question?